Hi, welcome to the next video. Let's continue. So the next section is 6.2 on applications. Six point two point one, fair games. Okay, so one application is something called fair games, and so it's section 6.2.1. And so here's the definition of a fair game. Definition: a fair game is one in which the expected net gain of each player is 0. Okay, so that's the definition of a fair game. A fair game is one in which the expected net gain of each player is 0. And so in this example 6.8, it's an example of a fair, we'll see an example of this, okay? So first I have to say what the game is. In the game Chuck-a-Luck, okay, so in the game Chuck-a-Luck, a player pays $1 and chooses one of the numbers from 1 to 6. 3 dice are then rolled. And if the number he or she chose or chooses appears 1, 2, or 3 times, the player receives $2, $3, or $4 respectively. Is this a fair game? If not, what should the fee be? To make this a fair game. Okay, so this is example 6.8. In the game Chuck-a-Luck, a player pays $1 and chooses one of the numbers from 1 to 6. 3 dice are then rolled, and if the number he or she chooses appears 1, 2, or 3 times, the player receives $2, $3, or $4 respectively. Is this a fair game? If not, what should the fee be to make this a fair game? Okay, so let's solve it. So I'm going to erase the top part of the board, and the example is on the bottom half. Okay. So I'm going to and so here's going to be the solution. Let capital X equal the net gain in dollars. Okay? Okay, so X is going to be a net gain in dollars. if the fee is $1, if the fee is $1, the possible values of X are, so X is the net gain. And so the player can either receive $2, $3, or $4, right? Or can receive $0. So if the player receives zero, if the player gets back $0 and pays $1, the net is -1. If the player makes $2 but paid $1, it's a net of 1. If the player makes $3 but paid 1, it's a net of 2. And the player makes $4 but paid 1, the net is 3. And so the possible values of X are -1, 2, and 3. Okay. Okay. So to find the probability of X, consider each roll of a die as a success in that trial. Okay, so to find the probability function of X, consider each roll of a die as success in that trial. Sorry, each roll of a die as a Bernoulli trial. And the appearance of the number chosen as a success in a trial, as success in a trial. Then little p, which is the probability of success, is 1/6. Right? If you choose one of the numbers, when you roll a die, there's 1/6 chance that the number is the same as the number you chose. So the probability of success in any trial is 1/6. And now calculating the probabilities of X. The probability that X, the net gain, is -1 would be the binomial probability where you have 0 successes out of 3 trials, where the probability of success is 1/6. Okay, so let me explain that again. So the probability that the net gain of the player is -1 is the probability that the number he chose appears 0 times. Right? He only makes money if the number he chose appears 1, 2, or 3 times. If it appears 0 times, he doesn't make any money, and he pays 1 to play the game. And so net of -1 is if the number he chose appears 0 times. A success is when he gets the number he chose in a roll. And so getting the number 0 times means 0 successes. He rolls 3 die, and so each die roll is a Bernoulli trial. So there's a total of 3 Bernoulli trials. The number of successes is 0, and the probability of success in each trial is 1/6. So every time he rolls a die, there's a 1/6 chance that the number he chose is the number that appears on the die. And so you just calculate the value of the binomial probability function. And so that's 3 choose 0, 1/6 to the 0 power, 5/6 to the 6 power. Okay, so how many ways can you choose 0 out of 3 trials? Times 1/6 to the 0, meaning he succeeds 0 times, times 5/6 to the 6 power, he fails 3 times, so that's a 3. Okay, that's 3 minus 0, which is 3. So how many ways are there to choose 0 out of 3 trials for him to succeed 0 times and fail 3 times? And so you calculate that. 3C0 is 1, and so 5/6 cubed is 125 over 216. So the probability is 125 over 216. The probability that the net gain of the player is -1. So next is the probability that the net gain is 1. And so what is the probability that the net gain of the player is 1? It's the value of binomial probability function of 1 success in 3 Bernoulli trials, where probability of success is 1/6. He rolls 3 dice. There's 3 Bernoulli trials. You want to get the value you chose once, so you want 1 success in those 3 trials, and the probability of success is 1/6. And so that means that 3 choose 1, 1/6 to the first power, 5/6 squared. Okay, good. So 3 choose 1 is number of ways to choose 1 out of the 3 trials to be a success. 1/6 to the first is 1 success, 5/6 squared is 2 failures. And so then that means that it's 3 times 1/6 times 5/6 squared. 3 choose 1 is 3. You calculate 3 choose 1. It's the same as 3 factorial over 1 factorial times 2 factorial. And you calculate that and you get 3. Okay, so this is 3 times 1/6 times 5/6 squared, so that's 25 over 216. 3 times 25 over 216 is 75 over 216. And so the probability that the net gain of the player is 1 is 75 over 216. Okay, so right now we're answering the question, is this a fair game, right? And so what we're going to do is find the expected value and determine whether or not it's a fair game. Okay, the next question will be, if it's not a fair game, what should the fee be to make this a fair game? Right, the fee right now is $1 to play the game. If it's not a fair game, we could change the fee to play the game and hopefully get a fair game after we change the fee to play. Okay, so I'm going to erase the question because I need more room for the solution. Okay, so we need to determine whether or not this is a fair game by calculating the expected value and seeing whether or not we get 0. A fair game has an expected value of 0. If the expected value is 0, it's a fair game. If expected value is non-zero, it's not a fair game. So let's just keep finding the probabilities of each value of x. So what is the probability that x is equal to 2? Well, it's the binomial probability function when there's 2 successes out of 3 Bernoulli trials where the probability of success is 1/6 in each Bernoulli trial. You roll a die 3 times, you get the number you chose twice, and so what that corresponds is with winning $3 in the game. If you win $3 and you paid 1, the net gain is $2. So that's the probability that x, the net gain in playing the game, is $2. You make 3, you pay 1 to play the game. So then that's equal to 3 choose 2 times 1/6 squared times 5/6 to the first. So how many ways can you choose 2 out of the 3 trials to be successes? Times 1/6 squared, which is you succeed twice, 5/6 to the first, you fail once. Okay, good. And so 3 choose 2 is 3. 1/6 squared times 5/6 to the first, that's 5 over 216. And so 5 times 3 is 15. That's 15 over 216. So the probability that the net gain of a player is $2 is 15 over 216. Okay, the probability the net gain of the player is 3. Well, what happens is that you roll the die 3 times, and if you get the number all 3 times, you make $4. And if you make $4 and you pay $1 to play the game, the net money you make by playing the game is $3, so x is 3. So this is the binomial probability function when you 3 successes in 3 Bernoulli trials where the probability of success in each trial is 1/6. You roll the die 3 times, you get the number you chose all 3 times, and so you succeed 3 times, and the probability of getting the number you chose is 1/6 in each trial, because there's 1/6 chance of, when you roll a die, of getting the same number you chose. Okay, and so that's equal to 3 choose 3 times 1/6 cubed times 5/6 to the 0 power. 3C3 is the number of ways of choosing all 3 trials to be successes, times 1/6 cubed, the probability of succeeding 3 times, times 5/6 to the 0, the probability of failing, that's for failing 0 times. And so then 3C3 is 1. Whenever you do NCN of anything, n choose n of anything, it's 1 because it's n factorial over n factorial times n minus n factorial. And so that's equal to n factorial over n factorial times 0 factorial. and that cancels to 1. 0 factorial is 1, so that's equals 1. So n choose n is 1 for any non-negative integer n. So here C3 3C3 is NCN when n is 3, that's 1. So this is 1 times 1 6 cubed times 5 6 is 0. And so this is 1 over 216, so it's 1 times that. So it's 1 over 216. So the probability that the net gain of the player is 3 is 1 over 216. Okay, so now we have the values of the probability that the x takes on each of all possible values. And so that implies that the expected value of x, which is the sum of all possible values of x up to x times f of x, is equal to -1 times f of -1 plus 1 times f of 1 plus 2 times f of 2 plus 3 times f of 3. And so that's the product of x times f of x over all possible values of x. So f of -1 is the probability x -1, which is 125 over 216. That's -1 of times 125 over 216. That's plus 1 times f of 1, which is 1 times 75 over 216. Good. And plus 2 times f of 2, which is 15 over 216. Plus 3 times f of 3, which is 1 over 216. And so you multiply all that and you add it, and what you get is -17 over 216. So the common denominator is 216, so it's -125 plus 75, which is -50. -50 plus 2 times 15 is -50 plus 30, which is -20. -20 plus 3 times 1 is -20 plus 3, which is -17. So it's -17 over the common denominator of 216. So -17 over 216 as a decimal is -0.0787. Right, you just multiply those and add them, and you get -17 over 216 or -0.0787. Good, okay. So the game is not a fair game. And that's because the expected value of x does not equal 0. Right? The definition of a fair game is one in which the net gain of each player is 0. And here the net gain is non-zero. The net gain is -0.0787. So net gain is losing, on average, a player would lose 7.87 cents. No, sorry, 7 cents. Yeah, 7.87 cents in the game. So the expected value is non-zero. Okay. So now the second part of the question was, what could we change the fee to be so that we get a fair game, right? So right now the fee is $1. Right now the fee is $1, and we get this expected value. Let's change the fee to $k and find the value of k that makes the expected value 0. Okay, so we're going to change the fee from $1 to $k, and then find an equation and sets e of x equal to 0, and it'll use k in it, and we'll solve for the k that makes e of x, the expected value, equal to 0. Okay. So we have the probabilities here. So I calculate the probabilities here. So here I'm going to leave this up, and that'll point out that the probability that x equals -1 originally was this. Probability x equals 1 was that. Probability x equals 2 is this. And the probability that x was 3 was that. Okay. So all this information is you can get from here. And we're going to use the same definition for x, right? And so all this information still applies, but I'm just going to use this space to continue working on the problem. Okay, so to help you follow what we're doing, remember if the dice appeared 1, 2, or 3 times, the player makes $2, $3, and $4 respectively. This is the dollars made. this is the number of times the chosen number appears, right? The times the chosen number appears, right? Okay, so if it appears one time, the player makes $2. If it appears 2 times, he makes 3. If it appears 3 times, he makes $4. And I'll just answer this. If it appears 0 times, right, he makes $0. Okay. Before, we had a fee of $1, so we took -1 for each amount to make the net. So the net was -1, 1, 2, 3. But now the fee is going to be K. So the probability, so first, if the fee is K instead of 1, then that means that if the number appears 0 times, then the player is going to make 0 minus K dollars. If the number appears once, he's going to make $2 minus the fee K. If the number appears twice, he's going to make $3 minus the fee K. If the number appears 3 times, he's going to make $4 minus the fee K. Okay, so the number appears 0 times, he makes 0 minus K dollars. If it appears once, he makes 2 minus K dollars. If the number appears twice, he makes 3 minus K dollars. And if it appears 3 times, he makes 4 minus K dollars. The probability, so this is the net, right? The probability of each one. We found the probabilities, but we just have to adjust the values of X. So for instance, here, f of -1, that was a net of -1, but that's because the fee was $1, right? This is the probability that 0 numbers appear. That's 125 over 216. Right? So before, the net gain of -1 was number appears 0 times, he makes $0 and he pays $1. Now, he makes $0 and he pays K dollars. So the probability that the net is -K is 125 over 216. The probability that the net is 2 minus K is 75 over 216. The probability that the net is 3 minus K is 15 over 216. The probability that the net is 4 minus K is 1 over 216. Okay? So now instead of losing $1 each time to the money made, he's losing K dollars, but the probability of that happening stays respectively the same. So this is 125 over 216, this is 75 over 216, 15, 1 over 216. Okay, so now we have our situation where for each value of X, these are the values of X, right? The net money that the player makes is the value of X. And so for each value of X, there's a probability of getting that value of X. And so we can compute the expected value as being a function of K. And so the expected value of X, we're going to set equal to 0, because we want this to be a fair game. Because we want a fair game. Okay, so we want a fair game. So we want the expected value of this X to become 0. And so what is the expected value of X though? Looking at this, it's the sum over X of X times f of X. That's what's 0. And so the possible values of X are 0 minus K. The probability is 125 over 216. Plus the next possible value of X, which is 2 minus K, which is 75 over 216. Plus the next possible value of K, which is 3 minus K. The next possible value of X, which is 3 minus K, times 15 over 216, plus the next possible value of X, which is 4 minus K times 1 over 216. And so that sum is going to be equal to 0. Okay, so that's E of X, and I'm just putting the equals 0 on that side because I ran out of it. So 0 is equal to that. That's the expected value. And so what does this become? You get a negative 125 over 216K. You get a minus 75 over 216K. You get a minus 15 over 216K. You get a minus 1 over 216K. right? This times this, this times this, this times this, and this times this. You have the other terms. You have 0 plus 2 times this, plus 3 times this, plus 4 times that. And so this is plus 2 times 75 over 216, plus 3 times 15 over 216, plus 4 times 1 over 216. 0 is equal to that. So I'm just expanding this out. And so now 0 is equal to the sum of those. And so that's minus 200, minus 216 over 216. That's minus 1. So that's minus 1k. Okay, plus, now that's 150 plus 45, 195, plus 4 is 199 over 216. And so if 0 is equal to negative 1k plus 199 over 216, that implies k is equal to 199 over 216. As a decimal, 199 over 216 is approximately 0.92. So if k equals 0.92, then the expected value is 0 and we have a fair game. And so we want the fee to be 92 cents. Okay, so the conclusion that we reach, is that if the fee is 92 cents, $0.92, 92 cents, then Chuck-a-Luck is a fair game, meaning the expected net gain of all the players is 0. Okay. The original expected value was negative 0.0787 with a fee of $1. The expected value was non-zero, so it was not fair. Changing the fee, make it a little bit lower to 92 cents or $0.92, then it becomes a fair game. The net gain, the expected net gain of each player becomes 0. Okay, and so that is the solution to that problem. Okay, good. Continuing. Okay, so the next section is 6.2.2, and that's on decision problems. Okay, so 6.2.2 is on decision problems. So this is example 6.9. Okay. A newly formed company, this is called a company. A company plans to send a number of employees to an annual one-day conference. So it's each year. Held in an out-of-town hotel. So I'll just say in a hotel. Okay, so the hotel offers a cheap rate of $30 per day per person. If reservations are received 30 or more days in advance. Okay, so if reservations are received 30 or more days in advance, the hotel offers a cheap rate of $30 per day per person. However, there is a cancellation fee of $15 per person. The regular rate is $40 per person. Okay, so the company's not sure how many it's going to send. Okay, so management feels if capital X is the number it will send, then capital X is a random variable with probability function f of x is equal to 1/4 for x is equal to 4, 5, 6, or 7. Okay, so the question is, should the company make advance reservations? If so, how many? Give the answer that minimizes cost. In the long run. So should the company make advance reservations? If so, how many? Give the answer that minimizes cost in the long run. Okay, good. Okay, so let me read the entire example from the beginning. Okay, example 6.9. A company plans to send a number of employees to an annual one-day conference held in a hotel. The hotel offers a cheap rate of $30 per day per person if reservations are received 30 or more days in advance. However, there is a cancellation fee of $15 per person. The regular rate is $40 per person. Management feels if x is the number it will send, then x is a random variable with probability function f of x equals 1/4 for x equals 4, 5, 6, or 7. Should the company make advance reservations? If so, how many? Give the answer that minimizes costs in the long run. Okay, so the solution, for here. So I'm going to include the left side of the board here, as I'm going to use this space for the solution also. Okay, so I'm going to let y sub I equal to the cost in dollars if the company makes reservations for I people. Okay, so y sub I is going to the cost in dollars if the company makes reservations for I people. Okay, so the possible values for y sub I, for y sub 4. Sorry, so this is the company, if the company make reservations for I people, right? So the possible values of x are 4, 5, 6, or 7. X is the number it will send, the company, right? So the company is sending 4, 5, 6, or 7 people. So that means that if the company is going to make reservations for I people, they're going to make reservations for either they're making reservations for I people, then they're going to make reservations for, we're going to have to consider I values of 1, 2, 3, 4. Okay, so what is the expected value of y sub 4? Okay, well, first off, if 4 people attend, the value of y sub 4 is 120 if 4 people attend. Okay, so what is that? Okay, so y sub 4 means the cost for the company if they make 4 reservations. The 4 is for the reservations, right? So that 4, the subscript 4 in the y, is the number of reservations they make. So if they make 4 reservations and 4 people attend, then that means they spent $30 for each of the 4 people, and it cost the company a total of $120. Y sub 4 could also equal, well, if 5 people attend, and they made reservations for 4 people, then that means there's 1 additional person that they didn't make reservations for. The regular rate is $40. And so 5 people attend, they make reservations for 4, and the reservations are $30 each person per day. So it's 120 plus another 40, that's 160. Okay? So if the company makes 4 reservations and 4 people attend, it costs the company $120. If they make 4 reservations and 5 people attend, it costs $160. Y sub 4 is equal to 200 if 6 attend. Okay? If 6 people attend and they have 4 reservations, they have 120 for the 4 people for reservations. There's 2 additional people, each cost $40, and so there's another 80 to the 120. But then y sub 4 is also equal to 240 if 7 attend. Okay, so if 7 people attend, then there's 3 additional people, each costing 40. So it's 120 plus 100. So it's $240 if there are 4 reservations for 70 people. Okay, and so so if 4 people attend, then it costs the company $120, and there's a 1/4 probability. Right? Because the possible values of X, the possible value of people attending is 4, 5, 6, or 7. So 4 people attend, there's a 1/4 chance 4 people attend, and it costs the company $120. There's a 1/4 chance that 5 people attend, and it costs the company $160. There's a 1/4 chance that 6 people attend, and it costs the company $200. And then there's a 1/4 chance that 7 people attend, which means it costs the company $240. And so the expected value of y sub 4, the expected value of the cost of the company if they make reservations for 4 people would be taking the value, all the possible values, all the possible costs that it could cost the company to make 4 reservations times the probabilities of each of those costs. So there's a 1/4 chance it'll cost the company $120 if they make 4 reservations. There's a 1/4 chance it'll cost the company $160 if they make 4 reservations. There's a 1/4 chance it'll cost the company $200 if they make 4 reservations. There's a 1/4 chance it'll cost the company $240 if they make 4 reservations. And so if you add up those products, you then get a value of 180. Okay, so the expected value there is 180. Okay, so E of y sub 4 is 180. So I'm going to put that number here. E of y sub 4 is 180. That's what we found there. Okay, so now we're going to continue for the next value. Okay, so I'm going to actually just erase this whole thing. Continue here. Good. So E of y sub 5, right, is the expected value of the cost of the company if they make 5 reservations. Okay, so y sub 5 is the cost in dollars for the company if they make 5 reservations. Okay, so y sub 5 is the cost in dollars if there's 5 reservations for the company, right? Okay, so now, okay, so if they make 5 reservations, there's 4 possible number of people that could show up, right? So y sub 5, what is that equal to if 4 attend? Okay, if they make 5 reservations and only 4 attend, first they made 5 reservations, so it costs $150 for the reservation. Then they had to cancel one of them, so it's 150 minus 15, that's 135. So if 4 people attend and they make 5 reservations, it costs the company $135. Now what is y sub 5 if 5 attend? If 5 attend, they made 5 reservations for 5 people. That's 5 times 30, that's 150. And then if 6 people attend, then y sub 5 is the cost of 5 reservations, 150, plus 1 non-reservation, which is under 40. That's 150 plus 40, which is 190. Okay. What is it equal to if 7 attend? If 7 people attend, well, they made 5 reservations, that's 150, and then there's 2 more people without reservations, that's 2 times 40, that's 80. So it's 150 plus 80, that's 230. Okay, so these are all the possible values of the costs on the company if they make 5 reservations, right? And the probability of each of them is 1/4. So you just multiply each of these by 1/4 and add the products to find the expected value of the cost for the company if they make 5 reservations. So E of y sub 5 is equal to 135 times 1/4 plus 150 times 1/4 plus 190 times 1/4 plus 230 times 1/4. And so you add up those products and you get 176.25. So E of y sub 5, the expected value of the cost of the company if they make 5 reservations is $176.25. So E of y sub 5 is equal to 176. Okay, so E of y sub 5 is equal to 176.25. Good. Okay, so y sub 6. So let's continue. And so let's find the expected value of y sub 6. And so to find the expected value of y sub 6 is the cost of the company if they make 6 reservations. Y sub 6 is the cost in dollars for the company if they make 6 reservations. Okay? So what is the cost of the company if they make 6 reservations? Okay, so let's find the expected value of that. So the value of y sub 6, if 4 attend, well, if 4 attend and they make 6 reservations, they made 6 reservations, it's $180. They have to cancel 2 of them because only 4 attended. So that's 180 minus 30, that's 150. Okay, 6 reservations, 180 minus 2 cancellations minus 30, 150. Now, if 5 attend, they made 6 reservations, which is 180 minus the one cancellation. So that's 180 minus 15, which is 165. Now, what is that equal to? If 6 attend, well, if 6 attend, if they make 6 reservations and all 6 attend, and it's just 3 of those, that's 180. And then if 7 attend, that means they made 6 reservations and 6 people go, it's 180, and if they pay 1 more for the additional person, that's 220. So it's 180 plus 40, which is 220. And so those are the values of y sub 6, the cost of the company if they make 6 reservations for each possible value of people who show up. Okay, and so to find the expected value, multiply each of these by the probability, which is 1/4. That's 150, and then you add up the product. So 150 times 1/4 plus 165 times 1/4 plus 180 times 1/4 plus 220 times 1/4. $178.75. So E of y sub 6 is the expected value of that random variable, which is 178.75. Good. Okay, so E of y sub 6 is equal to 178.75. That's good. Okay, and then let's find the expected value of y sub 7. Okay, so y sub 7 is the cost in dollars for the company if they make 7 reservations. E of y sub 7 is equal to, good. So y sub 7 is equal to what if there's 4 people that attend? So 4 people attend and they make 7 reservations. That's 210 minus 3 cancellations, 210 minus 45, which is 165. Now, if 5 people attend, okay, so if 5 attend, they make 7 reservations, so that's $210 minus 2 cancellations, which is minus 30. So 210 minus 30 is 180. Okay, so if 6 attend, okay, so if 6 attend, 7 times 30 is 210 for the reservations, minus 1 cancellation, which is 15. That's 195. And then if 7 attend, and then so if 7 attend, then there's 7 reservations, all 7 show up, so it's 210 with no cancellations. So that's 210. Okay, and so now each of those values have probably 1/4. You multiply each of them by 1/4 and add the products. So it's 165 times 1/4 plus 180 times 1/4 plus 195 times 1/4 plus 210 times 1/4, and then you add up the products there and you get 187.50. Okay, and so now that's the expected value of y sub 7. So that's on average how much it would cost the company if they made 4, 5, 6, or 7 reservations respectively. Okay, so you can see right, the average cost of that. So the question is, should the company make advanced reservations? If so, how many? Give the answer that minimizes the cost in the long run. If they didn't make any reservations, then they would just be paying $40 each time. So it would be it would be 40 plus 50 plus 60, 70. It would be $220 on average if they didn't make any reservations. So making reservations is definitely better. So the question is, should the company make advance reservations? The answer is yes, they should. Right? So they should, because all of those are cheaper than not making any reservations. The average is $220. So they should make advance reservations. Okay, so why? I'll write it down. Okay. So, right, if they don't make any advance reservations, then let's call it E of Y sub 0. They make 0 reservations. So the cost, if 4 people attend, would be $40 per person. And that would be $160 if 4 people attended with a probability of 1/4. If 5 people attended, $40 each would be $200, a 1/4 chance. If 6 people attended, it would cost $240 with a 1/4 chance. And if 7 people attended, it would be $280, 1/4 probability. All right, so if you find that expected value of 0 people, 0 reservations, costing the company, that's 160 times 1/4 is 40. 200 times 1/4 is 50, 240 times 1/4 is 60, 280 times 1/4 is 70. So this is 40 plus 50 plus 60 plus 70. And so 40 plus 50 is 90, 90 plus 60 is 150, 150 plus 70 is 220. And so that's $220. So the expected value, if they make 0 reservations, on average it would cost the company $220. That's way more than these all 4 of those. So they should make reservations. The answer is they should make reservations. They should make advanced reservations, right? Because the expected value, the average cost in the company if they make 0 reservations is more than the average cost in the company if they make any number of reservations, 4, 5, 6, or 7. Okay, and they should definitely make at least 4 reservations, right? If they know 4, 5, 6, or 7 people are coming at least, why make 3 reservations when you can make 4, right? So making 1, 2, or 3 reservations when you know 4 to 7 people are going is silly. You might, if you're going to make reservations, you might as well make 4 or more reservations. You can only save more money by making more than 1, 2, or 3 reservations, right? So we can eliminate those number of reservations as being the optimal number of reservations. Okay, so they should make advanced reservations. And so if so, how many? Give the answer that minimizes the cost in the long run, right? So to minimize the cost in the long run, you want the average to be as low as possible. And so the lowest average is this one, the expected value of Y sub 5. So that means on average, it costs the company less, the least, if they make 5 reservations. And so how many? They should make 5 reservations. Okay, so they should make 5 reservations because E of Y sub I is smallest when I is 5. E of Y sub 5 is smaller than E of Y sub 4, E of Y sub 6, and E of Y sub 7. 176.25 is the smaller of those numbers, right? And it's smaller than this one. Okay, and so that answers both questions. Company should make advanced reservations. They should make exactly 5 to minimize the cost in the long run on the company of sending employees to this hotel. Okay, and so that's example 6.9. So let's do another problem. So example 6.10. An inventory problem. So an inventory problem. In any 1 week, the number of requests for a magazine is a random variable x with probability function f of x is equal to 5/12 for x equals 3, 4/12 for x equals 4, 2/12 for x equals 5, 1/12 for x equals 6. Okay, so in any 1 week, the number of requests for a magazine is a random variable x with probability function f of x equaling to that piecewise function. Okay, so the magazine sells for $1. Each costs the owner 50 cents. Put the cents in 50 cents. How many magazines, so what abbreviates mags, how many mags should he order per week if to maximize profit, to max profit, to max expected profit? Okay, so you don't know how many requests there's going to be for the magazine, right? You may get 3, 4, 5, or 6 requests for the magazine. And so there's a probability associated with each number of requests, right? All the values of x are 3, 4, 5, and 6. Those are all the values of x. And so we want to know, we want to max the expected profit. And so we need a random variable to find the expected value of, right, to maximize profit. So we're going to let y sub I equal to the profit in dollars if the owner buys I magazines. Okay? Okay, so the question is, how many magazines should he order per week to maximize expected profit? And so we're going to consider all the possible number of magazines he could buy, right? So we're going to let y sub I be the profit in dollars if the owner buys I magazines. Okay? And so if there's going to be 3, 4, 5, or 6 requests for magazines, then the values of I we should consider is 3, 4, 5, or 6. And so what we want is the profit in dollars if the owner buys 3, 4, 5, or 6 magazines. And so we're going to look at the expected value of y sub I for those values of I. Okay, so what I'm going to do is I'm going to make a table here. And so let's make the table here. It's going to be 3, 6 rows. 1, 2, 3, 3, 4, 5, and 6. Okay, so little x is going to go here. So, well, x is going to go here. So it's going to be x, y sub 3, y sub 4, y sub 5, y sub 6 is rows. And then we're going to look at values of x being 3, 4, 5, or 6. Okay, so the values of x, 3, 4, 5, or 6 are the number of requests for the magazine. Either there's 3, 4, 5, or 6 requests for the magazine. Okay, and so y sub 3 is the profit in dollars if the owner buys I magazines. Okay, buys I magazines, that's the I there. How many magazines the owner buys. So if the owner buys 3 magazines and there's 3 requests, right? Then if there's 3 requests, he sells 3 of them. So he makes $3 because there's 3 requests for the 3 magazines he buys. He makes $3. And it costs him 50 cents each one he buys. And so it costs him $1.50 and he makes $3. And so he nets a total of $1.50 because he buys 3 magazines and that costs him $1.50. And then he makes $3 from selling all 3 because there's 3 requests for magazines. Okay, if there's 4 requests for magazines and he buys 3, then it costs him $1.50. He makes $3 because he sells all 3 of them. So he nets $1.50. And there's one person who requests a magazine who he can't sell it to because he only bought 3 magazines. And so the amount he makes is still $1.50 if there's additional requests. And if there's 5 requests, he still only makes $1.50. If there's 6 requests, he still only makes $1.50. So he'll make $1.50 if there's 3 requests because he buys 3 magazines. But if there's more than 3 requests, he'll just make $1.50 still. He won't be able to give everyone a magazine who requests it because he only bought 3. Okay. Now if he buys 4 magazines, then if there's 3 requests for magazines, then he bought 4, so he spent $2 to get those 4 magazines. But he can only sell 3 of them, so he makes $3. So he makes $3 and loses $2. He makes a total of $1. So if he buys 4 magazines and there's only 3 requests for them, he can only sell 3 of them, he makes only $1. So he makes 50 cents less if there's only 3 requests. Now, if he buys 4 magazines and there's 4 requests, that means he costs him $2 to buy those 4 magazines, but he makes $4 by selling all 4 of them. So he nets $2. And so now he makes an additional 50 cents if there's 4 requests for the magazine. Okay, and so now he nets a total of $2 if there's 4 requests. If there's 5 requests, but he only bought 4 magazines, he sells all 4 of them, and he just makes $2 still. And he makes $2 if there's 6 requests. Right? It doesn't matter if there's more requests. He's making $2 from the 4 he bought. He can only sell as many as he bought. Now for y sub 5, he buys 5 magazines, and so that costs him $2.50. But he only makes $3 because he can only sell 3 of them. So that's $2.50 from 3. He only makes 50 cents now. So if there's only 3 requests, he only makes 50 cents from buying 5 magazines. Now, if he buys 5 magazines and there's 4 requests, it costs him $2.50, but he makes $4, and so he makes $1.50. But then, if he buys 5 magazines and he sells all 5 of them because there's 5 requests, he makes a total of $2.50. Okay, and then if he buys 5 magazines and there's 6 requests, he can only sell the 5 he bought, so he still makes $2.50. Okay, now if he buys 6 magazines and there's 3 requests, then he spent $3 buying those 6 magazines, and he only makes $3, and so he makes a total of $0. If he buys 6 magazines, he can only sell 3 of them because there's only 3 requests. Now, if he buys 6 magazines and there's 4 requests, then he spends $3 to buy the 6 magazines, and he makes 4. So he makes $1. And if he buys 6 magazines and he sells 5 of them, he spends $3 and he makes $5. So he makes a total of $2. He nets $2. Then if he sells 6 magazines, which cost him $3, and he buys 6 magazines, which cost him $3, and he sells 6 magazines, he makes 6. He lost 3, made 6, he nets $3. Okay, so, those are all the values in this table. Okay, and so now you just find the expected value of each y. Okay, so you want to max expected profit. So you want to find the expected value of each y value, and the largest one would be maxing the expected profit. So e of y sub 3, well, if he requests 3 magazines, there's a 5/12 chance of that. And so he would make $1.50, but there's a 5/12 chance. But there's actually, he's going to make $1.50 no matter how many quests there are, and they add up to 1. So this is $1.50 times 1. So the expected value of y sub 3 is 1.5, $1.50. The expected value of y sub 4 is equal to, well, if you take each of these values and multiply it by their probabilities, y sub 4 could be $1, and the odds of that is 5/12. Plus, it could be $2, the odds of that is 4/12. Plus, another possibility is, well, it's actually still $2. The rest is $2. And so $2 is every other possibility, so it would add up to 7/12. 4/12 with 2/12 with 1/12, that would be 7/12. And so if you add up those products, you get 1.58. So now the expected value is 1.58 of y sub 4. So he'd actually make more money on average, if he bought 4 magazines than if he bought 3 magazines, which makes sense. Okay, and then e of y sub 5 is, you take each possible value of y sub 5, and that's 50 cents. The probability of that is 5/12. Plus 150, and the probability of that is 4/12. And then the value of 2.5, which is the probability of 2/12, plus the value, 2.5 would actually happen here and here, and that would be a total of 3/12. So you add up those products, and you get 1.33. So the expected value of y sub 5 is $1.33. That's less than e of y sub 4, which is 1.58. And then e of y sub 6 is taking each possible value of y sub 6, which is 0, which has a 5/12 chance of happening, plus 1, which has a 4/12 chance of happening, plus 2, which has a 2/12 chance of happening, plus 3, which has a 1/12 chance of happening. So that's equal to 0.92. Okay, and so now the expected values of those are these 4 values. And so we want to max expected profit. The y values are the expected value of the profit if he buys a certain number of magazines. And so he maximizes his profit if he buys 4 magazines. So if he buys 4 magazines, on average, he expects to make $1.58. That's more than the other 3. And so how many mags should he order per week to max expected profit? He should order 4 per week. Okay, so the conclusion is he should buy 4 mags per week to max profit. Okay, and so that's the answer to example 6.10. He should buy 4 mags per week to maximize profit. Okay, so thanks for watching this video, and I look forward to teaching you the next one.